Okay, good morning, guys. I'm gonna start off. With a quick introduction. Thanks again. This is Tom Zaderman from Skycatch, and welcome to our DJI Skycatch workflows for Earthworks management, featuring today Flywheel and Autodesk. So, quick introduction in the first minute. Then we're gonna talk about some DJI solutions. Skycatch solution, Autodesk will go over some of their solutions and workflow, and then most of the time, Dustin from Flywheel Beam Consultants will talk about their use cases and how they use drone data to simplify their workflows. We're going to go over on what's next in terms of webinars, and then for the most of the time at the end, we're going to have a Q&A session. Feel free during the webinar to log questions using the GoToWebinar control panel. All right, so a quick introduction. Dustin Williams, CEO and founder of Flywheel, years of experience in civil engineering, beam consulting, and AEC industry leader. Is really a trailblazer in using drones in his projects to facilitate, save time and money, and being able to communicate to stakeholders and customers on a daily basis. David Lee Fegerman from Autodesk, technical specialist of infrastructure. David is joining us today to talk about Autodesk tools in the context of Earthworks management. David Benowitz, program manager, B2B marketing strategy, DJI. Thank you, David, for joining us from DJI. David is focusing on accelerating the adoption of DJI drones into the commercial space. Myself, Tom Zaderman, I'm a product manager here at Skycatch. So David is going to start off with introduction of DJI and go over some of the main airframes used for the commercial space. Thank you very much, David, for being with us. I really appreciate DJI sponsoring this with us and collaborating on educating the industry. Please take it away.
Thanks for the introduction, Tom. And thank you. It's a great pleasure to be on this webinar with all the companies. So just for a brief introduction to what DJI is, we are the leading drone manufacturer globally, and we have over 7,000 employees now. And most of that is focused on our R&D, pushing really the technology to the next level. And what we're looking to do on the enterprise front is expand our solution offerings through our partnership culture. And that's really why I'm excited to be here with both Skycatch and Autodesk and Flywheel, is to showcase how our drones are used with our partners to become full end-to-end solutions next. And so what I'll hop into next is our basic solutions for construction. And so the first one we're going to go to is our Phantom 4 Pro. And the Phantom 4 Pro is our easiest and most ready-to-fly drone on the market today. But at the same time, with a very high-quality camera, you're getting the data you need as quickly as possible. Another thing to mention is that this Phantom 4 Pro does come bundled with our partnership through Skycatch as a rapid reality capture bundle. And be sure to check that out online. But so in addition to capturing really high quality data with the 20 megapixel 1-inch sensor, you also have a mechanical shutter so you don't get any blur on the edges, and an obstacle avoidance system so you're flying fully safely and as reliably as possible. Additionally, with a 30-minute flight time, don't have to worry about not being able to map your whole site. Next. And so with the next product we have is our Matrice 200 series drone, which is on the higher end of things. And this is both our most reliable, rugged, and versatile drone on the market today, and it will start shipping later in Q2. And what's great about this is that even though today you might only be using it for Earthworks for capturing visual imagery, stitching that together with Skycatch and then plugging that into Autodesk software, what it does mean is that tomorrow, if you have another project, another site with our readily available payloads or sensors that you can just swap out, you can attach a thermal sensor maybe next year, or even a zoom sensor if you move into inspections. And so it's really a drone tool that can be used for any project. So investing for your later projects that you'll be leveraging it for. Additionally, on the M210 RTK model, with the built-in RTK unit, you have much more accurate data when it comes down to to mapping your sites. And with improved flight time and whatnot, it's also probably our best mapping drone on the market. And with that being said, I'll pass it back to Tom, who will introduce the Skycatch solutions they have available today.
Thank you so much, David. Really appreciate it going through this. DJI has been doing a really great job in their solution, now penetrating into the commercial space as well. The better the data is captured, the better the results for your model and for analysis. So thanks again, David. A little bit about Skycatch. So the Skycatch starts with the capture phase of the data through a flight app on a tablet or on a mobile phone, running on an iOS devices, and it automates the DJI Phantom, Inspire, and Matrice, as well as the Skycatch drone. It has a smart routing algorithm, consistent routing, and also a terrain following feature that allows you to keep a consistent height above the ground for optimization of the data capture. You can also save the mission of the drone, so every time you want to fly the same mission and gather consistent data, you can just tap a button and the drone will execute the same flight every day, every week, or every month, if you will. After you capture the data, the data is uploaded to our cloud, and the cloud processing is our main core, is the core of our solution. We use those photos to generate different types of models in different file formats. The basic ones are 2D orthomosaic, 3D point cloud, and 3D mesh. We have also post-processing features. We generate contours, DSM, DTM, and those files are delivered in your desired coordinate system from anywhere from UTM, WGS84, state plane, and of course your arbitrary local projection if needed. After the data is processed, you can either get the files and use them on other softwares, or you can visualize and analyze them on a simple web application that is based on multi-user team collaboration for the entire team, designed with big enterprises in mind and big teams in mind for big projects. It has 2D and 3D viewers. No need to attach any software. Simple 2D and 3D viewer on the web. It can accept CAD overlays, so you can lay your blueprints onto the data capture in order to validate that the design matches the build. You can run volume measurements and area measurements, 2D and 3D measurements, and you can generate simple URL links and share them with your teammates, stakeholders, and customers with no need for them to have credentials to the Skycatch app. That's all for us. Now I'm going to give David Lee a few minutes to go over a recent case study that they have been doing with the Army. He's going to go over a video that will show workflow in the context of Earthworks, and then he will recap and go over the main takeaways. Thank you, David Lee, for being here with us. We really appreciate it. We're really grateful for this partnership and sponsorship with Autodesk on this one, and we'll be glad to have you with us here in the future on a monthly basis. Please feel free to take it away.
Thank you, Tom, and welcome everyone. It's quite ironic this webcast is going on right now, because 4 weeks ago I was in North Dakota, and everything we're talking about here came to play. Skycatch, the DJI Inspire drone, all of that. We were working with the Army, looking at new techniques on data capture. And if you look at the top image right here, this is a site. It's actually 4 miles of fence line that we've got in red, and then at least a 30-acre site right here, which they're using to. They actually, the Army actually wanted to see a terrain model of it and up-to-date orthometric imagery. So we met with the Army, laid this out, and then came in and set control. And I've just got a blow up here. We went in the field and put targeting and shot it with GPS. That was adequate, tied in the North Dakota State Plane system. And before we even used the terrain or the targeting, we had taken this Bing type map up here on the right and used Skycatch to map a pattern out to capture this data. We went out in the field with the drone. We had the targets on the ground, and we shot this. So 4 miles of road, 30 acres of site. Here's just a little blow up of it. In fact, right in here, you can see the fence in this pond, but that pond right there is the pond on the bottom. What amazed myself and the Army, you know, Skycatch worked great. We shot the whole thing, everything in 6 hours. We came in and reduced it, and even before we applied GPS or the ground control, the coordinates from the latitude, longitude, the metadata on the imagery, put this thing within 2 to 3 feet of true space. So which showed us that we could do this with or without ground control, depending if you want to do recon in that. Without ground control, it's great. With it, it's, you know, we can tighten it right up perfect. So with Civil 3D, we can take lat long data and drop it into any coordinate system. So that's what we did here. That was an extremely good session. Next slide, please, Tom. Now this is a workflow, and with Autodesk, we'll start out right here with what's called recap, and that's part of the what's called AEC collections. And so we can take in data right from a drone directly here and then index it into a format that all the other Autodesk products use. Notice the coordinate system application applied, everything. So this indexes the data. That can be LAS data, it could be PTS, it could be any format. Then we roll to the Earthworks environment right here. So all we do is index it at the minimum. We'll load up a point cloud here, and this is some brand new technology we're coming out with, where if you have people on site, vehicles on site, buildings on site, and what you want to get is bare earth. And in the instance here, there's buildings and things you can see, there's trucks, there's people. We don't want to do bare earth calculation with them there. So this tool you're seeing right now will come in, and this is real-time processing on this data. It will take and find the different classifications. In other words, bare earth, buildings, trees, any of these things that separates them. And at the same time, we can take the point cloud and reduce it to about 10% of its size by sampling techniques and still have as accurate of a model. So what we're looking at here in a moment is the terrain that's actually captured, you know, from that. And when I look over here, this is what's called theming. We're going to look at that in a minute. But right here, you see just the bare earth. You don't see trucks in it. You don't see buildings in it. All of that is processed out real time. And that's always been a tough thing. How do you get rid of that data? So now we're visualizing. Notice you got all these categories on the right. Those are the classifications. All you see is brown. But that's because we used the thin process where we didn't, in this one model, show all the other categories, just the bare earth. Now, all I'm doing right here is coming in, exporting this to what's called IMX, which when you go into Civil 3D, you simply attach this. So when I reach out, Earthworks did all that cleaning, and it could make linear features and vertical features at the same time. But when I do this, the coordinate system does matter. So I came from a lat long system. I'm coming into a NAT 83 type system here. I'm sorry, UTM here. But it could be state plane, it could be UTM, it doesn't matter. Automatically when this data comes in, watch this, you'll see that it's in the right location. So when we use the Civil 3D geolocate with imagery, we can backdrop this and we see that thing fell right in the right spot. That's what we did with the Army. And in fact, myself even, I was shocked how accurate it came in before we even ran control on it. So what happens here, we've got this in, it's a surface in Civil 3D. Right now, as simple as that, that was real time. What we're doing here is just a quick example, create a dummy surface, and put a perimeter around it. We'll put a 3D poly out there snapping to the contours. That'll make a flat plane out there of existing ground. And this is a case where we'll create a surface and we'll do what's called a triangle volume, where we compare, and Dustin will show much more of this as he goes in his later in the presentation. But here we can take that flat surface, compare it against this drone-based surface, and get what's called a volume surface, which will tell us the volumetrics of the model. And at the same time it does that, it can show us the cut, fill contours, or do mark, cut, and fill. So from this, immediately we'll turn these other surfaces off. And when we look at volume, and this is real time, it calcs the volume just like that, very quick. And one other thing is, it may be that, and we'll turn off these contours on the others and look at just the one we created. This could be where you fly it day after day. You use that Skycatch same pattern, and you compare day to day instead of what we just did right here. So your volumetrics day over day could be calculated, or day over, whatever period you like, comparing one point cloud to the next. This is just fantastic for that. So Tom, if you would, the next slide, just to put a wrapper on this. So on the Autodesk side, we've got what's called recap, and that'll index aerial data from drones with just cameras, or drones with LiDAR and cameras, or mobile, or terrestrial. All the LiDAR data is indexed through recap. The extraction is done through Earthworks. That's information extraction. Bare earth surface, brake line surfaces. We've got some fantastic brake line extraction tools from the point cloud, automatic, as well as vertical feature extraction. And then lastly, what we just showed, in which Dustin will show a lot more of, is Earthwork. So we can take the Earthwork data from Earthworks, roll it into Civil 3D directly, and we can do all of our volumetrics, as well as our grading, as well as our road design, pond design, everything else. And so, Tom, I'm going to roll it back to you, but that concludes my little section right here. Thank you.
Thank you so much, David. That was very helpful. Really appreciate you walking through this. And I'm sure the availability and immediacy of using drones will really ramp up the usage of Civil 3D and the rest of Autodesk Suite on a daily basis. All right. So that's the main part of the webinar. We're gonna now let Dustin from Flywheel to present his company, what they do, talk about some of the use cases, and then go over the cut and fill calculation workflow and talk about the way it impacts his business and makes his customer happy. Thanks again, Dustin, for joining us. Really exciting to have you here with us, and please take it away.
All right, thank you very much, Tom. Good morning, everyone, and thank you for joining us today. I'm really excited to be here today with industry leaders, Skycatch, DJI, and Autodesk. We will be showing you, we will be combining our collective knowledge and providing you with some creative Earthworks solutions this morning. Yeah, so let's go over Flywheel. We are a site information modeling and reality capture expert. Collectively, we have decades of experience in civil and virtual design in the construction industry. Our goal at Flywheel is to use that vast experience, as well as the most up-to-date technology, to create efficient workflows, reduce errors, and create complete coordinated environment to solve our clients' large and often complex tasks and problems. We're an anywhere workforce, therefore we're able to work on projects around the world, locally or remotely. We're headquartered in Santa Cruz, California, where we serve the San Francisco Bay and Monterey Bay areas. But we also have a local presence in Las Vegas, Nevada. Flywheel provides a broad range of services to our customers in the AEC industry, but our core services include site infrastructure modeling and reality capture with drones and terrestrial laser scanners. So today we'd like to share a couple of use cases with you, 3 to be exact. The first one is contractual negotiation. Maybe not the most glamorous subject for some, but something that is certainly extremely important on all projects. We also see problems arise when the customer provides the project team with obsolete survey information. This can easily lead to a multitude of compounding problems. Initially, the incorrect site balance calculations will lead to an inaccurate bid, and this could lead to you losing your bid, or if you do get the bid, you will not have an adequate budget to complete your scope of work, which often leads to change orders and the risk of litigation. So what we've seen in the past is like a hands-off, address the problems as they arise kind of approach. And this is partially due to firms relying on old surveying tools, which are oftentimes too time-consuming in the case of total stations and GPS units, or in the case of LiDAR, too expensive. On to the next slide. Your goals at this stage of the project are likely to assess the ultimate project needs, what the project needs are, and what it will take to meet those needs. You're going to want to set the expectations with the client that you can meet those needs also. Doing your due diligence and providing a proposal you can achieve while keeping your client happy is important because it reflects positively on your company, can save you time and money, and could also keep you out of hot water. So how do you achieve this? One way would be to fly a drone over the project prior to committing to that scope and fee. You could take that drone data and analyze it for pitfalls, as well as any competitive advantage you can find. Also, comparing this data against survey and design provided by the owner, you could identify potential issues and how you could solve them. And it may give you an edge on your proposal. And another use case would potentially be maintaining balanced site and progress. So during construction, especially during the mass grading exercise, you always want to know what the site balance looks like. Sometimes that leads to an anxiety of not knowing, even more so when your client asks for you specific questions about the current status of the earthwork operations. And so constant monitoring of this information with previous methods was often a cost prohibitive and often leading the superintendents to guesstimating the current volumes in between the infrequent surveying efforts. Moving on to our goals here. So you want to know exactly where your site balance stands on a regular basis, and you want to identify any potential problems early, because the earlier you catch those potential problems, the quicker you can devise a solution and avoid any long-term costly problems. And this will allow you and your team to stay in alignment and on schedule. So how do we solve this? Simply fly the site as often as you have activity that you want to monitor. Typically, we are flying active project sites daily, sometimes weekly. You're going to want to take that data and review it regularly and identify any potential issues from this unique perspective that you have, this aerial perspective, and take that necessary corrective action before it costs you a significant money or time or credibility. Also worth mentioning is the regional managers who are not on site daily will have better insight on how their projects are progressing between their site visits. And our final use case is the reporting to stakeholders. So leaving customers and stakeholders in the dark can be very frustrating for them, and can lead to further miscommunication, potentially back charges when issues arise or deadlines are missed. The communication via undocumented conversations or vague emails or reports lacking the visual reference may cause long-term damage to that relationship with your client. Reporting progress on a regular basis can provide a client with confidence that you're getting the job done. You can foster a better relationship with your client and glean more efficient work from your team by keeping everybody posted with the information that they need on a regular basis. It will make you and your firm more credible, and the appropriate level of transparency will reduce the risk of litigation. So how do we achieve that? We can begin to do this with regular reporting, such as daily horizontal and vertical mapping with the drone captures. Also, adding information to the progress reports regarding site-wide completion status, individual items recently completed, as well as any areas of concern and their proposed solutions will greatly benefit everybody involved. That covers the use cases that we have for you today. So how do we actually do that? I think this example workflow will give you a really good idea of how you can achieve this. So the first step in preparing data, this particular site is a 30-acre site in the Bay Area of California. We flew it with the EVO 3X that we have from Skycatch, and we took our photos after the 45-minute flight and uploaded those to the Skycatch portal. We got an email back saying that our information was ready, and we downloaded the LAS files, which are the point cloud files from the Skycatch portal. We then imported those as Autodesk had referred to in their video presentation. We're going to do a very similar process utilizing the same engine, and we're going to walk through that very quickly here and then move on to the management of the data. But this LAS file gets imported into the recap product, and the engine processes it so that Earthworks can read it. And Earthworks is going to take its algorithm and it smartly classifies and extracts the ground-only points in this scenario, and provides you with a decimated surface that has just the information you need. Like I said, this is a 30-acre site. It took about 45 minutes to fly, and it returned about 43 million points. After processing it in Earthworks, it went down to less than 7,000. And those are all that provides a similarly accurate surface as if you were to process it with no filter. It's actually more accurate considering that it's classifying only the ground information and getting rid of your ancillary information, such as trees, people, equipment on site in this scenario. So that allows us to move on to the next step, where we're going to manage the data. So Earthworks will, in my workflow, Earthworks extracts out a decimated point cloud that's an RCF file, and what I tend to do is X-reference that file into my Civil 3D drawing and use the create surface from point cloud function. There's multiple ways of doing the same thing in Civil 3D and Autodesk product. The magic of it all is the classification coming out of Earthworks. So in this example, we're using two point cloud data sets. It's a part of the repeat flight capabilities of the Skycatch app. We flew it, basically this is at the beginning of the project, and then one toward, a month later. This is a reporting of that month's total earthwork. So it's walking through the steps in the video to the left. Simply creating a surface, and you can see that we're using a naming convention, which I feel is extremely important in managing your surfaces. If you're going to do this long term and you're going to capture data on a regular basis, either daily or weekly even, you're going to end up with dozens of surfaces. And just a simple naming convention with the project site and the data to capture will really benefit you in the long term. So that'll move us along, and it'll allow us to do the next step, which is analyzing that data. Similar to what Autodesk referred to, is you're going to end up with two surfaces, and this could be either, in this scenario, where you have two data sets, point cloud data sets from a drone flight. What we often do is also compare it against a design subgrade surface to our current interim grading surface, or we'll compare existing to design. There's a lot of different scenarios that you can use the same workflow for. So we're going to create a third surface here. It's called a tin volume surface, and it compares the two data sets that we have. In this case, we're using a flight from before, which is the base, and then the comparison surface will be our more recent surface. On the screen to your right, we added a boundary to the surface because all we want to analyze here is, in this scenario, is what is currently being graded. The entire site is not being graded. It's about 2/3 of the site. So we're comparing that site. And then we're displaying it with elevation banding. I think this display method is the quickest way to get a grasp on the severity of your cuts and fills across the site. We set the elevations, depending on the project. On a fairly flat project like this, we will use 1/2 foot or 1 foot. I use 1 foot on these. So you can see it's anywhere from 16 feet of fill to 16 feet of cut, essentially, on this particular project. The 1 foot of elevation banding is a really good choice for this one. So it displays different shades of green and red depending on the severity of the cut and fill, and you're left with that excellent visual. And then you can take that tin volume surface and you can bring it into the volumes dashboard. So if you go to the Analyze tab in Civil 3D, you can click on the button that says Volumes Dashboard, and it's green and red, and bring that up and bring that surface into it, and it'll instantly give you a really good way for managing all of your surface information. At some point, you're going to have multiple surfaces in there, and you'll be combining data, whether it's because you have different grading zones across the site, or you want to compare different dates, or different things like that. This is where you're going to want to combine that information. And keep it separate, but then you can combine it here. So that will lead us to our next step, which is reporting that data. So you're going to, within the volumes dashboard, you can do a one-click report. It will combine all of your data that you have for cuts and fills, cut and fill factors if you have those, the area which you were analyzing, the total square footage or acreage, and provide you with a net cut fill and total it. So if you had multiple line items here, it would total it up for you at the bottom. The next thing that we find extremely beneficial in some of the newer versions of Civil 3D is the ability, this is an alternative to the elevation banding, it's an Earthworks plan production. And in the same Analyze tab, you can click on the Earthworks plan production, and you can select whatever surfaces you want to compare. In this scenario, we only have 2 in this file, and we're going to compare those 2 surfaces. And this is what it will display. In the upper right portion of the slide, there's a key. It provides information on what the text is representing, whether it's cut fill volume or elevations of existing grade, what have you. So that'll process right out of the Civil 3D, right out of the box, will process you a very nice, clean, and very beneficial plan that you can then report to either your team. It's very detailed information, so it's really good for the field staff, or you can report it to your clients, depending on their how savvy they are. So we'd like to go through what a report might look like. On the right-hand side, we have the standard daily project earthwork report. You can see it lists the activities, the date, the percent complete of the individual activities, or the overall grading in this example. Also, the planned handoff date of that zone or that overall grading, and whether or not you're on track or not. So if you're not on track, it has a note section, and we're proposing solutions like if we're behind on pad grading, maybe we're going to work through the weekend and try and beat the rain. Or if it's just a resources issue, we're going to, bring in more scrapers and trucks and off all that dirt faster. Those types of things. And so that's the snapshot. There's also, this is a really good use for this cover page, is a really good use for transmitting the information on the current data sets that were used to create some of these earthwork calculations. So you can use the current aerial data capture section and provide a public link to the Skycatch portal. This is a public link. You don't have to have any credentials to sign in and look at it. And that makes it extremely simple for the less savvy users. To the right of that, we have the earthwork cut fill summary for this particular analysis. And below is a visual reference. It's the elevation banding that I think is very telling. So our main takeaways: we want you to identify on your own project and company-wide any use cases that you can see. You have a drone now. It's not a huge effort. This project was 30 acres, as I mentioned, and it only took us 45 minutes to fly. It's not like you're sending a crew out to survey it for several days and then post-processing that in the office for several more days. It's a pretty quick process. The computers are doing a lot of the work, and you never know when you're going to want that information. More often than not, we're finding that we are analyzing data that we captured because we wanted it for the future, but we didn't know we were going to need it. The cost of gathering that data because of the limited efforts far outweighs the cost of actually capturing the data. So another takeaway would be manage and analyze your data with the latest software and workflows. This can literally save you hours, if not days, from previous methods, and which would allow you to do it more often. There's a lot less guessing in that scenario, and why not? It's quick and efficient. So, and then the final step would be reporting it regularly. If you keep your client happy, you're going to keep yourself profitable, and then that way everybody wins. So Tom, I think that's what I have for you guys today until the question and answer.
All right. Thank you very much, Dustin. That was very helpful. Very grateful our audience. So much information packed into this. All right. So we're going to move to what's coming next for us in terms of webinars. The next one will be on establishing in-house drone operations for GCs, and we're going to learn how to deal with FAA regulations, how to train your team, and how to scale drone operations in your organization, and how to manage your drone fleet. After that, we have in the backlog getting started with reality capture, deep dive on accuracy, beam coordination part 2. We're going to give you some more beam-related workflows, and a webinar on energy inspection. If you have any comments, suggestions, questions, or if you'd like to participate on one of those, please reach out to me at tomz@Skycatch, and we'd love to hear your feedback and ideas. All right, time for the Q&A. We got here a few questions during the session. So question for Autodesk, David Lee. Any plans to have a Mac version for Recap 360?
I'm afraid I cannot answer that. I can get an answer, and hopefully we can post it, Tom, to the folks on this call. I do not know the answer to that one off the top of my head. Sorry.
Okay, thanks, David. We'll try to get this answer offline after the webinar. Question for probably everybody can answer this. Eric is asking, is there a rule of thumb for deciding how many ground controls to establish? Is it 4 per acre, 4 per site, etc.? Dustin, do you want to take this question?
Sure. I guess you're going to want to do it on the perimeter of your project. It's the best place to put them. And you're going to want them to be no more than a few hundred feet apart. Typically, on a site that's around 30 acres, we're throwing down a half a dozen if we want to use ground control points. And we're doing that around the perimeter and out of the way of the active construction so that they are definitely not moving.
Right, thanks, Dustin. We have a question from Jake. Probably I can take it. When is the Skycatch Android version coming out? So the question is for the Evo 3X, the Skycatch drone. The flight app is running on an Android tablet. For DJI Android support, it's going to come out later this year, probably during the summer. Next question to Autodesk. Question about Civil 3D. How many points can Civil 3D handle?
That's a very good question, and that depends on which civil object you're talking about. If you're talking about a surface model in Civil 3D, a Civil 3D surface, you generally don't want to go over a couple million points. However, if you're talking a point cloud, the recap format can go up to 20 billion points with a B. So when you insert a point cloud, like Dustin did into Civil 3D, even though it is several billion points, it still moves ultra fast because of the indexed RCP RCS combination. So bottom line, surface related only, I wouldn't go beyond 2 million points. And again, like Dustin said, he took a very large file and went down to 7,000 points on it. That's where recap comes in. I'm sorry, that's where the Earthworks piece comes in on the decimation, but maintaining the accuracy. So you could have 3 billion points in a point cloud and then come out with 10,000 points and have just as accurate of a model in Civil 3D. So it's all workflow related, but very good question. That's it, Tom.
Thank you, David. That question for Skycatch. Does Skycatch have terrain following capability? And what terrain database is used for Skycatch terrain following? Dan is asking this question. So yeah, we do have terrain following capability. Currently, we use a database from an SRTM mission. But for our enterprise and for customized solutions for our big clients, we can use the terrain database with the point clouds our customers collect with their drones. So what we do is we're going to take a point cloud from a high flyover of the site, and we're gonna put this point cloud into the database and extract the X-Ways information. So the drone for the following flights will be able to accurately follow the terrain and accommodate for daily changes on site. Next question for probably Dustin. Dustin, what's the benefit in having pilot license and people who can fly drones in-house as opposed to having this outsourced to drone service providers?
In-house, I think the benefit is that you can, it's really the cost of the person going out, and they're typically going to be on site. They're not traveling 1 hour, 2 hours to get to the site and then flying for 1 hour or 2 hours. That significantly reduces the effort there. It's also a consistent flight time, or not flight time, but if you're doing the repeatable flight, you're getting a consistent analysis, and then you know what areas you can focus on too. If you could convey that to an outsourced service provider, but I think in-house it just makes it more likely that you can provide daily flights. Is the biggest thing in a cost-effective way.
Got it. Thanks, Dustin. Very good answer. That's probably a question for Autodesk. Benjamin is asking, where can we learn more about the use of Earthworks as you presented us during this webinar?
About the Earthworks, did you say use of it?
Yeah.
Okay. Let me tell you, we've got several YouTube presentations up there where you could go to YouTube and key in recap and Earthworks. Another one I will tell you, I personally recorded about a half-hour training video that steps from taking the LiDAR data, index, recap, then in Earthworks doing bare earth, but also advanced linear feature extraction, and then roll to Civil 3D. And there's a company called Retrieve Technology. You can look it up on Google, Retrieve Technology. Bounce them a note and say you'd like to, see the training video on Earthworks and that relative to LiDAR. And I know they'd be happy to take care of you. Okay?
Thank you, David.
Yep.
Next question for Flywheel. Is it possible to use just the geotech pictures and the GCP base stations and process the Linux file from the base station observation in order to generate an accurate surface for Earthworks quantities? Or would you always recommend ground surface targets or GCPs?
You can tie in. So I guess I should qualify this with, I'm flying the precision package that Skycatch offers, and that is RTK enabled. Also, DJI has the new M200 RTK enabled drone, and you can utilize the base stations on site. And since they're local, it could provide you with a slightly more accurate data for post-processing from the RTK network. And so it depends on what the use is for your project. The ground control points are sometimes we just put them down, even though we're flying an RTK, we put them down just for a backup. As far as surveying and accuracy goes, one of the best takeaways you can take from this is that you want something that's repeatable, and the only way to do that is through ground control points. But they're not absolutely required for an accurate end product. So you could use the RTK, the local RTK network, or you could use that base station. You can tie into either one of those.
Thank you, Dustin. Next question from James. Probably I can take it. Can you show again the flight planning process and how the overlap and side lap is set, and also how the shutter trigger rate is computed? So our smart flight app basically allows the user to just set the altitude and the area that needs to be surveyed, and then in the background, we, based on this altitude and the size of the area, calculating and doing the calculation of the routing in a way that a front overlap for the photos is about 75 to 80%, and the side overlap of the routes themselves is about 60 to 65%. Those values are necessary for good photogrammetry and 3D reconstruction, and everything is done automatically in the background. The shutter trigger rate is also computed and synchronized with the drone speed and with the drone altitude in order to achieve those percentage of overlap. Next question. To Autodesk, Martin is asking, do Autodesk applications allow independent data storage, or does every application require an Autodesk portal?
Well, I'm not positive I've got that right, but you probably mean, does it have to go on an Autodesk cloud type thing? For example, Earthworks, when we do the cloud, or I'm sorry, the extraction from this information, that has the option to go on the cloud or on the desktop. So you have an option. Recap is about the same thing for LiDAR-based, ground-based LiDAR. You can take it and run it from a desktop, or you can use what we call our A360 and post and run up there. On the image processing, generally that is where you would check it into an Autodesk portal and reduce it, and then pull that down. You can pull it down on your desktop, but we have had versions that run on desktop. At the moment, we're basically running with it where it runs on the cloud and uses the horsepower of the cloud. I hope that answers that question.
Thank you, David.
Mm-hmm.
Next question from Eric. Does obstacle avoidance on the Phantom 4 Pro work while flying the program mission from Skycatch? I probably can take it. The answer, Eric, is yes. The obstacle avoidance, DJI did a really good job in exposing this feature on top of any other feature that built by an external company. So basically, the obstacle avoidance feature will override whatever else controls the UAV in case the drone is close to an obstacle. So the answer is yes. Another question from Andres. In USA, the use of PPK, and in Europe, the RTK. Here in Sweden, we have a very good RTK network. Can we use an RTK drones who is prepared for PPK? Yes, Anders, the question is, the answer is yes. Both DJI and Skycatch provide RTK-enabled drones, and Skycatch drone is actually also a PPK, also based PPK. So you can use any RTK network as long as you're in the coverage area. Log the data on the network during the flight of the drone, and then Skycatch doing processing will fetch this data collection log from your network. Obviously, you need to provide us the credential for it. We will fetch this file, apply it into the processing, and apply the data collection and accuracy into your model. Question from James. Can you comment on state of the art for drone-based LiDAR? Have the costs come down to the point where it's attractive to drone operators? David B, do you wanna talk a little bit about drones, DJI airplanes that can carry LiDAR?
Yes, so we've seen quite a few people integrate the various LiDAR units, specifically the Velodyne Pucks, onto our Matrice 600 platform. That being said, they're a little bit hard to use. But there's the company LiDAR USA, one of our DJI Enterprise dealers. If you're interested in getting access to a unit, reach out to them if you're interested in that specific platform. But I think we'll see in coming months, specifically with a few recent announcements from LiDAR companies, that LiDAR will get small enough to the point where we can put it on something more along this, a smaller size airframe.
All right, awesome, David, thanks. All right, guys, I think the time is up. Thank you very much for joining us. We hope it was helpful for you. Please let us know if you have any feedback, requests. You can contact me at tomz@Skycatch and let me know your thoughts and feedback. Thank you, Autodesk, DJI, and Flywheel for joining us and collaborating with us on this. We're really grateful that we kind of gather forces in order to educate the industry to accelerate adoption. Thank you, everybody. Have a great rest of the day, and we'll see you on the next one.
Thanks, everyone.
Thank you.